Thank you very much, Mar, Valerie, Juan Manuel, and Antonio for this welcoming, and I will go directly to the first presentation of today. We have to be very tight today because we have a very long agenda. We have to adjust all the presentations to what is needed. The agenda is this. As you can see, there will be a first part in where we are presenting the project, the results, we will go to the visit, etc., etc. And during the afternoon, we have a very, very interesting session organized by Clean Hydrogen Partnership in order to explain what is happening with this hydrogen imports approach. In any case, my introduction is talking about the Port of Valencia. You know that we are looking for net zero emissions, and this project is a very important project to provide some solutions for the port terminal operators in order to decarbonize their facilities. And in this case, I have to say that the Port of Valencia is very important. I don't know if you know that is the fourth most important port in Europe, and this is a very crucial issue to explain because is really needed to be very close to the innovation, very close to the decarbonization of the activities. You will see here's the location of the port, the layout of the Port of Valencia, and we will. I want to explain more or less the location of the machines because in this case. The Rich Stacker was working in the Mediterranean Shipping Company Terminal Valencia. In this case, there is another machine, the yard tractor in Valencia Terminal Europa by Grimaldi Group. It's a Robo terminal, and also we will see in Chita Key the hydrogen station. The hydrogen station is a fixed and a mobile one, and you will know about that in a few minutes. The budget of the project was 4 million euros and the duration was 7 years. It's the first application in Europe of hydrogen technologies for port handling equipment in real operative conditions. We are not building a project, we are building pilots. And in this case, it's very important. Some European projects, you see a lot of literature, demos, etc., etc. But here, you will see that there are real machinery in the ports and operating in the terminals. I want to say thank you because we are 10 partners. We started with 9 partners only, and now we have another one that was crucial also to understand the logistics for that. But of course, the Port Authority of Valencia is very important. The support from them. They started with this idea, try to boost this solution for the port terminals. They are also escorting the port terminals that they want to test these machines. It was very, very important. Also, the challenge for Centro Nacional of Hidrógeno and Athena. They are really, really very hard workers, try to define some solutions in that sense. It was very difficult from them because they are research institutes and institutions, and now we see that they did a very good job. Also the end users, MSC Terminal Valencia and Grimaldi, without them, the end users, it's impossible to test anything, because we are talking about machines working in real conditions. And finally, the industry. We'll start with Carburos, in this case, was the last one coming, but they provide the solution for the logistics and the hydrogen, so it's the molecule is very important. And also we have also Ballard that was inserting the fuel cell in the yard tractor in this case. And of course, not the last, but Hyster-Yale that made the first Rich Stacker in the world, completely designed from scratch, propelled with hydrogen and also in a gas that brings some ideas and expertise regarding the use of hydrogen in Spain. This was the timeline. I have to say that it was very difficult because we are talking about 7 years. This is another thing that I want to state. When we are thinking about real pilots, we need time, and sometimes the projects are not enough duration in order to go that. I'm not going to talk about the pilots because there is a session for that, but we have a hydrogen supply, we have also a ridge stacker, and also we have a 4x4 yard tractor. Results. Duration, 7 years. We have to say that from 2019 to 2025, we had a coordinator before. I don't know what is. Josep Sanz was the first. I had the honor to continue the work, and also my colleague Aurelio is the technical coordinator of the project. So for me, it's very important to understand that during 7 years, there were a lot of changes. It was a hard reality. We started with a budget of 4 million euros, more or less, and we are expecting to finish the project with 7 million of expenditure. So in this case, I want to say that the commitment from H2PORTS, in this case from Athena, was crucial. Also the end users, that they put money directly, apart from the budget, in order to address all the objectives of the project is very important. We have to say that we found very difficult the adaptability and resilience because we had 4 amendments. I say 4 amendments because it's very important to explain that we had the COVID in the middle. There was a delay, and we started doing the meetings, etc., online. So it was very crucial. Even though I have to say that it was very difficult also to have a dinner together of the consortium is really important. Also, we had a problem after the COVID with the H2 supply. We have to include carburos metálicos in order to bring the hydrogen, and also to the logistics that is involved in the 3 pilots. So it was crucial this part, and we include this 10th partner to the project. There was delays regarding the crisis of the supply chain. You can imagine, mainly for the yard tractor. There was a delay in the supply chain because we are talking about tailored spare parts. It was very difficult, sometimes 7 months, 8 months, try to bring the spare parts. It was very difficult for them, also for H2PORTS, replacing the fuel cells and all the spare parts. So it's very important. And finally, delays in testing the final pilots. When we go to the real, there is a problem regarding how to address all the things that you have to manage in a port. You have to train the stevedores, you have to train the port workers, you have to train a lot of things. You have to standardize some guidelines, try to change the contingency plan, and a lot of coordination. So this was the explanation of having 7 years instead of 4. Collaboration is crucial. Always we say that, but we have like a reflect in the more than 650 meetings among the consortium, project officer, externals, stevedores. They are here also, very commit with the project from the first moment, and also more than 100 people working in the consortium. So this is a very good numbers. And finally, guidelines and facts. We will have more than 30 deliverables produced. We have produced papers, procedures that are preparing the basis for the port, and finally ad hoc documentation for ports. Main results, again, you can see here an iceberg, because sometimes in the project we don't know what is behind the water, but here we have to say that we put the Port of Valencia as Innovation Center for the use of hydrogen. We are talking about first pilots in Europe using green hydrogen, a huge operational experience gain. Also, we are talking about risk assessment and contingency plans of the Port of Valencia. We are now, as I mentioned before, the coordination of stakeholders was crucial. We were managing some manuals for hydrogen at port terminals, and the adaptation of the terminals to adopt these pilots and to prepare also them for the supply. And also we have the approval for the use of hydrogen powered port machinery on board ro-ro vessels. I think Athena will explain that there was a specific study from RINA try to allow that a machine could go on board the vessel with hydrogen. So it's very important that. I think this is the first time in the world, I don't know. But and also the stevedores training and port workers involvement. Regarding the communication results, as Juan Manuel said before, we started with a stakeholder advisory group. We started with only 10 or 12 entities, and we gathered more than 80. In this case, you can see here the ports. The ports were thinking about that this concept was very interesting, and they bet on this. Also public authorities, port maritime entities, associations and industry. We had six meetings with a lot of experts. I couldn't put all the presentations here, but there was a lot, and you can also follow the website to take these presentations. And our idea, as a result, is to continue working in this stakeholder group, because it's like a mandate from the Port Authority in order to boost this discussion. Regarding the communication results, I have to say that we have an average of 3,600 users in the website. Also 5 newsletters, more than 25 press releases, more than 60 conferences attended for all the staff in H2Ports. Over 500 followers in LinkedIn and more than 500 news generated during these 7 years. So, concluding and going to the point, we have to say that hydrogen technology successfully integrated into port operation is a reality here in the Port of Valencia. We are talking about that hydrogen. In the first moment, we thought that, hydrogen is very dangerous. No. Hydrogen is not dangerous, it's very, very safe, and we see that there is an efficient performance under real conditions in this case. We follow some procedures, coordination and training that is needed. Also, we see that hydrogen is a potential reduction of emission and pollutants on port terminals and on board. So maybe Athena will explain later, but when you put the yard tractor, 4x4 yard tractor within the vessel, the emissions are zero directly. This is a very important objective and goal that we have addressed and achieved. And finally, we see that there is a high potential scalability and adoption in other ports. You can imagine I'm not nervous because we are here in a family. We are the hydrogen family in this case. I have to say that it's very difficult to summarize all the things that we have done in 7 years, and you will see during the session. But my idea is, in order to facilitate that, I'm gonna put you a video. Okay, so this is the final video of the project in order to explain all these things that maybe you cannot see, and you will see when the video is starting. So please.
H2PORTS is a pioneering initiative developed at the Port of Valencia, whose main objective was to evaluate and demonstrate the use of hydrogen in port operations. This project, coordinated by Fundación Valencia Port and financed by Clean Hydrogen Partnership, has set a global precedent for cleaner, safer, and more sustainable port terminals. During the project execution, 2 pilots were tested, a reach stacker and a yard tractor, which were the first experiences in Europe of using hydrogen technologies in port handling equipment under real operating conditions. The hydrogen fuel cell-powered reach stacker was designed and built by Heister and tested at the MSC Terminal Valencia. This reach stacker was engineered to match the performance of its diesel equivalent, both in lifting capacity and operational speed. Its design incorporates a fuel cell module combined with an electric traction system and independent hydraulic motors. This allows for efficient energy distribution, especially during peak operations. The machine integrates 4 high-pressure hydrogen tanks, following SAE standards for easy global compatibility. With a single refueling, it can operate for a full shift, and under the right intensity, even complete 2 shifts without interruption. Moreover, dock workers gave positive feedback on the reach stacker, noting similar performance and comfort to diesel models, with the added benefit of less noise, less vibration, and 0 local emissions. This pilot has demonstrated that hydrogen technology can be seamlessly integrated into high-demand port operations, replacing fossil fuels without compromising efficiency, safety, or operator comfort. The Hydrogen Yard Tractor is a prototype port vehicle with a hybrid fuel cell battery powertrain, capable of performing all tasks required for cargo loading and unloading. The conversion of the vehicle from a diesel unit was carried out by Athena, with the support of University of Naples Partheno, ANEA, and Grimaldi Euramed, and tested at Valencia Terminal Europa, part of the Grimaldi Group. The vehicle is equipped with a 70-kilowatt fuel cell module provided by Ballard, a 25-kilowatt-hour battery pack, and 4 350-bar Type 3 cylinders, providing about 6 hours of continuous operation, matching a full work shift. The project faced major challenges, notably the development of an advanced energy management strategy to balance power flows between fuel cell and battery, ensuring efficiency and durability. The pilot proved that existing port vehicles can be effectively converted to hydrogen, delivering high performance while reducing noise and emissions in terminal operations. The location of both pilots in different terminals of the port required a flexible solution, the Mobile Hydrogen Refueling Station. This innovative, tailor-made solution for delivering hydrogen to both pilots was developed by Centro Nacional del Hidrógeno, and it has been operated by Carburos Metálicos, Air Products Group, as the project's renewable hydrogen supplier partner. In addition, Carburos Metálicos supported the project with refueling logistics, training, and safety coordination across partners. The hydrogen refueling station consists of 2 subsystems, a fixed unit housing the compressor and storage system, and a mobile unit, equipped with high-pressure cascade tanks and a dispenser. This station is capable of refueling both hydrogen-powered vehicles within a single shift, providing flexibility, operational autonomy, and high safety standards. It delivers hydrogen at 300 and 450 bar with a capacity of up to 55 kilograms per day and a maximum dispensing rate of 3.6 kilograms per minute. This enables rapid refueling of both machines within a limited time, one of the key operational advantages of hydrogen technology in port environments. This mobile concept has proven to be both technically feasible and operationally effective, offering a scalable model for hydrogen deployment in other complex and regulated environments such as ports. H2PORTS has brought together key partners in the fields of logistics, energy, and innovation. Fundación Valencia Port, the Port Authority of Valencia, MSC Terminal Valencia, Grimaldi, Carburos Metálicos, Air Products Group, Ballard, Athena, Heister, Centro Nacional del Hidrógeno, and Enagás. H2PORTS has also managed to lead a group of 80 relevant stakeholders who have regularly attended workshops to discuss hydrogen use in maritime transport. With an investment of 4 million euros, this project has demonstrated the viability of hydrogen at European ports. Beyond the technology, H2PORTS has tackled key issues. It has addressed regulatory analyses for hydrogen use at ports. It has created pioneer operational guidelines for mobile refueling stations. It has highlighted the relevance of specific training and safety protocols and the need of a collaborative approach. And it has laid the groundwork for hydrogen integration in port master plans. The operational phase of H2PORTS has provided valuable real-world data, offering a unique operational experience that has proven essential for understanding the practical challenges and opportunities of hydrogen technologies in port environments. While the full impact is still being assessed, the project has proven that hydrogen-powered machinery can become a safe, viable, and sustainable alternative in port logistics, paving the way for achieving zero emissions in the medium to long term in port operations. H2PORTS has ended, but its outcomes will guide the next generation of green port projects.
And that's it.